Welcome to the AI Risk Report, the monthly threat research briefing for security leaders who are focused on defending AI systems. I'm Diana Kelley, the CISO at Protect AI, and this month's episode is all about the rapidly growing volume of attacks targeting large language models, also known as LLMs, at runtime. That's when they're running. This means things like jailbreaks, denial of service kind of exploits. We're going to give you an expert breakdown of what's real, what's repeatable, what matters, and what CISOs and their teams really need to know and should be watching for right now. And to help us do all of that, I am so delighted to be joined by one of my colleagues at Protect AI's Layer team. The Layer team focuses on securing Gen AI, generative AI, during live operation, often known as runtime. And our senior applied researcher for Layer for this runtime security team in AI is Chris de Vries, and he is here with us today. Chris, thank you so much for coming here and joining us. Chris brings deep hands-on insight into how these threats are evolving and how we should be thinking about defense in this new frontier. Welcome, Chris.
Thanks, great to be here. And yeah, sure, there's an explosion of attacks coming out at the moment. I'm looking forward to talking about them.
There are. Yeah, so let's jump right in. Let's start with jailbreaks. That's something that I think a lot of people hear about. It's a foundational, essential concept for the audience. But sometimes I realize when I'm reading articles that there's confusion about what a jailbreak means, what it means in the context of an LLM versus an operating system. So, Chris, please, can you break down for us what is a jailbreak, why does it matter, and why should CISOs and other risk experts be concerned?
So yeah, a jailbreak is an attack that's trying to bypass the original security training of a large language model. Typically, large language models are trained in an unconstrained way, and then they have additional training that's performed to provide guardrails, so they provide the correct type of output and do not provide dangerous or malicious or even damaging responses. So to give a concrete example for this, you could have an attacker who is trying to bypass this safety mechanism by trying to convince the LLM that it is also a chemist, and the LLM is a chemist, say, working on a pandemic problem, and they're trying to convince the LLM to give them a recipe for anthrax. And because they're a colleague, this kind of conflicts with its internal training. And from time to time, you can actually bypass the model by giving it fictional scenarios like this. So there's also lots of other attacks in the similar vein, such as rephrasing prompts to word them in different ways that can sometimes get around these guardrails using different personas. So that's the type of attack I listed then, but then you can try as many different personas as you want, and maybe one slips through. And also logic tricks to get the model to be confused and therefore bypass its training.
So it's fascinating that we can use different personas to jailbreak LLMs. We understand you gave the example of making anthrax. So that's a security concern, obviously, if that LLM is giving out information that could be harmful. Are there other security concerns or other kinds of harm that can be accomplished with jailbreaks?
So yeah, jailbreaks can be combined with other attacks as well to make them more easier. So it can make prompt injection easier because the guardrails of the model have been removed, and other attacks then become easier as well. So this can lead to leaking sensitive information, like what the system prompt is, like kind of the additional information that the developers have put into the system prompt that tells the system how to behave. And once the attackers know that information, then they can use that to attack the system. It can also leak sensitive data. Perhaps a large language model has been trained on or has retrieved information from some sort of internal resource within a company. And the jailbreaking also leads to an increased likelihood that this information could be leaked when it wasn't before.
Not good. Okay. So thank you so much for helping us align and understand on what jailbreaks are and why they create risks for organizations. But I was wondering if we could start talking a little bit about what's happening out there in the wild. So one of the trends that we've been seeing with our research at Protect AI is the pace at which the jailbreak attacks on LLMs are accelerating. And what used to be just isolated proof of concept research has really grown into this whole litany of shared techniques. As we know, attackers, one of the ways that they get better is that they do share what works and what doesn't work, and knowledge and information with each other. So, that's really creating this accessible, repeatable approach that the attackers are using. You and I were recently talking about a popular jailbreak repository on GitHub, and you noticed that you saw some trends in there, including the rapid acceleration of attempts to jailbreak. So I'm just wondering, from your perspective, what do you see as driving this? What are the attackers getting out of these jailbreaks? And why should this be a turning point in terms of response for defenders?
Okay. I think the attackers have been driven a lot by research so far. So if you have, and gaining notoriety for publishing this research and also getting credit from their peers for this. So if you look at the publication rate of jailbreak papers, we've already on Archive, which is a popular ePrints repository, we've already passed the number of papers we saw last year of 191. So we're already up to 221 this year. So we're looking at having over double the number of jailbreak attacks being put out there. And I think, attackers are implementing this, but it also gives a chance for defenders to implement mitigation approaches to these attacks as well. So we can use the information about these attacks to generate adaptive models, AI models that will detect these attacks at runtime and allow a security organization insight into what's happening, as well as the chance to block them before any damage happens.
Yeah, and that's really fascinating, because you're really on the cutting edge. You're seeing all of this research. You're also working to see how the tools that you're building at Layer and Protect AI really help to stop or alert when these attacks are happening. Can you dive a little bit deeper into how Gen AI, how does AI help to protect AI, especially against these emerging threats like jailbreaks?
Okay. With these emerging threats, they don't always follow exactly the same pattern. So attacking tools, or even the red teaming tools that we offer at Protect AI as well, will adaptively update these prompts until they find one that works. So if you just have a static bunch of rules that say if these words occur in this order, then it's an attack, this will probably fail pretty quickly. But by having an adaptive system on the other side that can generalize from the examples it's been trained on, allows it to better protect against the attackers who are also using AI.
Got it. Okay. Kind of fighting fire with fire, right? For anybody that's just tuning in, right? Yeah. Anybody that's just tuning in, we just had a really nice discussion around the fact that, jailbreaks, they started as a sort of an academic proof of concept issue. They are real, they are growing, and they are happening out in the wild. So we know that the jailbreaks are grabbing the headlines, Chris, but you see a lot more kinds of attacks at Layer, being so close to what's happening with LLM security. And I was wondering, what other sort of attacks, especially the ones that occur to AI and Gen AI at runtime, should CISOs and their teams be aware of?
I think some newer emerging threats are denial of service attacks, where attackers try to create inputs that will use a lot of resources or completely disable the system. A simple version of this is like asking an LLM to write a novel about a rabbit and a bear 1,000 times over, and we'll just sit there and keep on doing this. There are already other ways to mitigate these attacks, as well as just putting hard cost limits on outputs, but they don't always stop the problem, especially if it's been sent to a third party. So most people are using a large language model from one of the frontier labs like OpenAI or Anthropic, and this can cause costs to spiral and also make the system completely unavailable.
Yeah.
We've also have been looking into the topic of bias exploitation. So can you get the model to say things that are unwanted in a biased way, either about people or the state of the world or any other social biases that you wouldn't want to see in the output, especially from a company that's offering a product. So we're working on developing, detecting bias as well in outputs, so security teams can have a real-time insight in if there's any kind of biased outputs coming out of their systems. And I think this is all going to continue to explode as all these models become more multilingual and multimodal. So the first research paper showed that if you just translate attacks into a different language, then they kind of bypass the model's safety mechanisms. I think the models have now updated to deal with this, but this will only continue to be a problem as we, go into vision language models, and we're starting to see the first vision exploits come around as well. And eventually, I think the models will take sound in as a basic input as well, and many other inputs as well. But the first three would be language, vision, and sound. And when they're all combined in one model, it just adds to the number of potential attack vectors.
Yeah. Each mode creates another attack surface within that system. Yeah, it's some pretty serious stuff. To double click a little bit on the denial of service or the sponge attacks, why is this such a big concern for security teams, especially around the LLMs? A lot of people may not understand the compute costs with LLMs. So as we see those sponge attacks, in addition to creating an availability issue, what are some of the other problems that come from a DDoS on your LLM?
Okay, yeah, you were mentioning costs there. So the inference costs of these large models get very expensive very quickly, especially if it's a large organization. So, while it might cost $100 million to train one of these models, if you have enough people using it at once, you can very quickly exceed those costs. Probably for most organizations, it's an order of magnitude smaller than that, but with $100,000 is not a small amount of money either. If you can quickly just burn through compute resources, because typically they're very elastic on the other end. And beyond that, there's also the question of availability. So as these become part of more and more critical infrastructure that people rely on to do their everyday business, if you can take these out, then this can lead to losses as well.
Wow. Okay, Chris, you have given us a huge amount to think about in terms of what can be done at runtime to disrupt the AI functionality and potentially make it run in ways that the owners of those systems don't want it to. So given all of that, I was wondering, do you have some practical steps that security leaders can take to protect their AI deployments, especially as these runtime threats are accelerating?
Yeah, for sure. I think there's been a big shift in software development as AI has been adopted. So the maintenance cost of software has gone a lot from development time to also maintaining it after it's deployed with AI. So with traditional software, you run all your tests in the test environment and you're pretty sure that your software is correct. But with AI systems, the landscape changes as the system runs. So this requires better runtime telemetry and real-time monitoring. So Layer is one of these approaches that can do this. We detect many different types of issues with AI systems, from malicious to non-malicious as well, to detecting unwanted types of content beyond just bias to even personally identifiable information. So I think this requires like a layered approach. So static rules still work. All the AI systems I've seen still always have some layer of static rules because you have to respond to things in real time. Maybe you need to block all outputs containing a certain word because this has become a new exploit that's not patched yet. But you also need to layer these with adaptive defenses and AI-based defenses that will try and adapt to incoming attacks as they occur.
Yeah, it's that reminds me of back when I was working at Microsoft, and we were Microsoft was developing the Sentinel SIM, which was very AI driven. But looking at the metrics, there was this really great research showing that the the Sentinel running with just AI was nowhere near as effective than when you had Sentinel with AI and some static rules that together, because we know static rules get brittle and they're really heavy overhead. But when you added the AI and the static rules, as you're talking about, it was like just the functionality just exploded. It was really amazing to see. So from your observations, are there any misconceptions? So we just had a good one, which may be a misconception for some folks. They may not understand that effective AI systems may actually use some expert aspects, i.e. some static rules to actually improve usability. I wonder if there are any other misconceptions that CISOs or defenders and security defenders might have about how to defend against LLM attacks.
Yeah, I think as I was mentioning earlier, the adaptive nature is very different to what's happened previously in software development, where there can just even be complete distribution shifts in the way people use your application over time, and the system will kind of respond to this, and so do you have to respond to this as well. And it's not just covering kind of one part of your organization. Like previously, most of this would have happened in development, and you would make sure that within the engineering org, everything was ready to go once you launched it. But now security and product are more involved because these problems emerge after the fact, and the system needs more ongoing maintenance than traditional software systems. So I think it's going to lead to much higher collaboration, especially between security and engineering departments.
I love that. I think the closer security and engineering can get, I think the better. So I love that that's where you think that this is going. I think that's a very positive trend. Any final thoughts that you have, Chris? Given that, again, you're on the front lines of defending AI at runtime, any final thoughts you have about where things might be going or what you're focusing on in the future to continue to defend these systems?
Yeah, I guess my biggest concern would be keeping up with everything that's happening. There's like several exploits coming out a week, but I think this is also a great opportunity to build and have something that keeps up with state of the art. So it's kind of a double-edged sword. It means it's an exciting area to work in, but it also means that it's quite intense at times. But I think over time it will slow down eventually as kind of all the exploits are saturated, and we'll have a more solid knowledge base that's not shifting as quickly to rely on, and will make things easier for everybody involved.
I love that. And here's to when we get a little bit more saturation, we can slow down and really focus on making sure that these systems are shored up and protected in the way that organizations need to be able to leverage this fantastic technology. Thank you so much, Chris, for sharing your insights here. It's been an absolute pleasure to learn from you about the threat landscape for AI runtime security and how it's evolving. And thank you for sharing all of that knowledge with our audience and the cybersecurity professionals tuning in today. If you are just tuning in, if this is the first time you've seen our show, we do have a lot of research, a lot of resources, a lot of tools and guidance to help you secure your AI deployments. You can find all of that information just by visiting us at protectai.com. And we want to thank you so much to the audience for being here and joining us for this episode of the AI Risk Report. We'll see you next time.